Now, if we have a chain rule and we notice that there's been a chain rule that has occurred, we just anti-chain rule it. If we realize that we've had the derivative of some function with a function inside, with the derivative of that inside function on the outside, then we know we have taken the chain rule. But sometimes that's hard to recognize. So there's a couple of techniques that will work for anti-chain ruling. Sometimes we can substitute the inside function for a variable, write the antiderivative of that, and solve. It's called a u-substitution. It always works. Now, if we can recognize the antiderivative, we can use the pattern that we notice. Now, if we think we might see a chain rule, we figure out what the innermost function is, and we're going to let that function be u. So we'll end up seeing something where we have f prime, the derivative of some inner function, with the derivative of that function there. Let's see how that works. Okay, so in this example, what would be considered an innermost function? Well, it looks like it's x cubed, right? So I'm going to let u be x cubed. What would du dx be? Well, that would be 3x squared So let's see what we have. 3x squared is du dx times the sine of x cubed, which was u, dx. Well, the dx's cancel, and so I have sine of u du. What is the antiderivative of sine? Well, the derivative of cosine is negative sine, so the antiderivative of sine would be negative cosine. Now, we didn't start off with u. That was x cubed. So all we have to do is substitute it back in. What about here? What could I let be u? Well, I am thinking, I'm going to use a different color, of that 5x plus 1. Not really loving it. Plus 1. So du dx would be 5. Right? Now, I don't have a 5 there, so I'm going to rearrange this a little bit and do something a little different. I know I can rewrite this as 1 over u, right? dx, if I rewrite dx, I can rewrite this as du equals 5 times dx, du divided by 5 equals dx. You're going to see why I'm doing this. This time, I'm going to substitute dx with du divided by 5. Or in other words, 1/5 of 1 over u du. Can I take the antiderivative of 1 over u? Sure. That's natural log. There's a 1/5 on the outside. Natural log of u plus c. Well, what was u? Well, u was 5x plus 1. What about the next one? What would be u? Well, I'd make the innermost function u. 4x squared plus 1. So du would be 8x. Oops, du dx, sorry. So I could rearrange that to be dx equals du divided by 8x. With me so far? Let's substitute in what we can. So we have a 2x. I replace this with u. And dx, I'm going to replace as du divided by 8x. Well, 2x divided by 8x is going to give me 1/4. And that leaves me with u to the 8th du. Do I know how to take the antiderivative of u to the 8th? Sure, anti-power rule. Now still have that 1/4 on the outside. I'm going to add 1 to my exponent and then divide by the new exponent. So that's going to be 1/36 u to the 9th plus c. Well, what did u start off being? It is 4x squared plus 1 to the 9th power. Ooh. Oh gosh, we've got e's and cosines and cosecants and oh my. Let's let the innermost function, cosine, be my u. So du dx is negative sine x. Now if I rearrange that, I would have dx equals du divided by negative sine x. So let me rewrite my function. This is going to be e to the u. Now dividing by cosecant is the same as multiplying by sine x. dx is going to be replaced with du divided by negative sine x. Hey, those cancel. Leaves me with negative integral of e to the u du. Do you know how to take the antiderivative of e to something? Well, that one's super easy. I'm going to have negative e to the u plus c. Negative e to the cosine x plus c. So let's see about the pattern method. See if that's sometimes easier or sometimes not. So in the first example, the innermost function would be like 9x. Well, what's the derivative of 9x? Well, it's 9. So really, the antiderivative, I divide by that, so it'd be 1/9 e to the 9x plus c. Double check. The derivative of e to the 9x would just be e to the 9x times the derivative of 9x. So it works. The derivative of the innermost function here is 5. So I need a 1/5. Cosecant, cotangent, cosecant, cotangent. It's usually negative cosecant, cotangent, so I'm going to make this negative. And that's the derivative of cosecant. In this next one, what would you consider the innermost function? What do you consider g of x to be? So I'm going to kind of make a note on the side. I think g of x is 3x squared minus 1. Well, what does that mean g prime would be? Well, the derivative of that is 6x. That's what I'm going to divide by. So we had that 3x that was already there. And this was 1 over 3x squared minus 1. So that would be natural log of 3x squared minus 1. And the derivative of that is 6x. So let's see what that gives me. 3x divided by 6x is 1/2 natural log of 3x squared minus 1 plus c. Well, does that really work? You can always test that your antiderivative is correct by taking the derivative. The derivative of this would be 1/2. Natural log would be 1 over 3x squared minus 1 times the derivative of 3x squared minus 1. So times 6x. Well, if I simplify that, I've got 6x in the numerator, 2 down there, that's 3x, over 3x squared minus 1. It works. What about the next one? Oh, goodness. To the 10th power. Well, that means that my innermost is this one. So let's leave the x minus the 4 there for a second. If I take the antiderivative of that, it's going to be 3x squared minus 24x to the 11th divided by 11. But we're also supposed to divide by the derivative of that inner function, which would be 6x minus 24. Well, what's going to happen there? 6x minus 24, if you factor out a 6, you're going to have 6 times x minus 4. The x minus 4's will cancel out. Oh, plus c. And so you're left with, I don't know why there's not enough room here, 3x squared minus 24x to the 11th divided by 11 times 6, which is 66, plus c. Whew. Now let's use the shortcut on some of the ones we did earlier. 3x squared times sine of x cubed. Well, the 3x squared, the antiderivative of sine is going to be, well, negative cosine of x cubed divided by the derivative of x cubed. We're left with negative cosine of x cubed plus c. So it does kind of work. The next one, 1 over 5x plus 1. Well, 1 over something, that would be natural log of 5x plus 1 divided by the derivative of the inner function, which should be 1/5 plus c. Here, leave the 2x for a second. We have 4x squared plus 1. Antiderivative, we're going to add 1 to the power, then divide by the new exponent, and also divide by the derivative of the inner function. Let's see what happens there. The x's are going to cancel or divide out. 2 goes into 8 4 times. That leaves me with 9 times 4, which is 1 over 36. 4x squared plus 1 to the 9th power plus c. E to the cosine x over cosecant x. Okay, so I'm going to leave the cosecant there for a second. I'll make that 1 over cosecant. Well, 1 over cosecant would be sine. And the antiderivative of e to the cosine x would be e to the cosine x divided by the derivative of cosine x, which is negative sine x. These divide out and leave me with negative e to the cosine x plus c.